So we're at Microsoft Research in Cambridge. That's my wife, Mary.
Well,
So I'm here. Where are we? First of all, this is not Redmond, right?
let me close the door.
Oh, you can just. It's nice and quiet here. That tells
No,
me
it's a bit different here.
it tells me it's a little bit different than Redmond.
And
We're in Cambridge, England, right?
Cambridge,
This is our first international.
Massachusetts.
This is our first international interview. So thank you for inviting me.
Well, thanks for
all
taking
the way
time on your
across
vacation time to come out here.
Yeah.
I relocated here.
So who are you, first of all? So I don't even know your name.
Oh, I'm Mitch Goldberg.
Mitch Goldberg. Great. And what's your position here?
My position here, I lead a small team that is responsible for tech transfer to the product groups. So a lot of the research, what I call late-stage research, we want to fast-track into the researchers, from the researchers' hands into the product groups.
Right. So you're similar to Kevin Schofield then, right?
Kevin Schofield is a general manager in Microsoft Redmond, and he does lead a lot of, amongst numerous other things, technology transfer efforts as well. And there's an MSRPM team. There's only about 5 or 6 of us on the MSRPM that's actually based here. I work really closely with Phil Fawcett in what we call a push-pull relationship, where we're constantly trying to best understand strategically what product groups, what state they're at, what milestone they're at, or if they're in the design phase, when do we really want to engage with them, and then also really having an intimate understanding of a lot of the research that's going on here and trying to decide when's the best time to engage with a product group.
Right.
I, in addition, have I relocated a senior dev manager out from Redmond. Prior to joining us over a year ago, he was the dev lead with PNRP, also called PeerNet, or the peer-to-peer in the Windows Networking Communications Transverse Connectivity Group. And we have several folks that report through him, and a lot of times there'll be some late-stage research that perhaps isn't something that's going to be consumed by a product group at the present time. It could be because Longhorn, it doesn't have an opportunity at this point in time, or say Digital Imaging Pro isn't at a point where they're ready to consume something because of other commitments and timelines that they have in their product lifecycle. So we'll actually productize that ourselves and look at other possibilities. Perhaps, in fact, you'll meet with one of the researchers, Karsten, who's working with digital imaging and being able to make a seamless tapestry. And it's actually quite intelligent about knowing from, say, a subdirectory of images that you have, what might be the interesting things like pull-out faces or flowers or animals. But knowing you want to place the animal probably on a lawn, and you want the sky above, and mountains belong up above and not below, and a waterfall perhaps belongs, flowing this way. And I think you'll have a lot of fun seeing that. But for instance, that's one of the projects tapestry that we're looking at, actually being able to productize.
Why do you research in Cambridge? I mean, why does Microsoft want to invest in research around the world?
Not every scientist, academic, or researcher wants to move to Redmond. And clearly this is a hub for a lot of the great minds in the academic and research communities that perhaps don't want to move to Redmond and enjoy living in the Cambridge area.
When I took the taxi right here, I saw a lot of really neat colleges and universities, old colleges.
Well, that's another thing we're able to tap on the wealth of folks that are going through that university here and be able to keep them here.
So who has the best computer science departments in the universities near here?
Well, Cambridge is definitely very strong in that area, and that and Oxford as well. And I'd say there's probably only a third of the folks who are actually from Cambridge University. A lot of them are from all over Europe. This really is a European lab. So don't confuse the Cambridge. It could be called the MSR Europe, actually, quite easily. As you probably know, there's also a lab in Beijing, China. There's a new one in India, and 2 in San Francisco, and of course the large one in Redmond.
Yeah, we've been to the San Francisco one, and of course the one in Redmond.
I still haven't been to the San Francisco one.
Oh, really? That's really neat.
These days,
They're really smart people down there. It's a lot of fun. Now, you're from Redmond, right?
Yes, I relocated here about 5 years ago.
And you've been working at Microsoft for 10 years?
Yes.
All of it in research, or?
No, I've only been with research for the last almost 3.5, almost 4 years.
Okay. So what did you do before?
Well, I started in the developer relations group. I was the telephony technical evangelist. I also spent some time as a program manager with TAPI, and I spent some time in the Microsoft Mobile Devices Division, MDD at that time it was called.
Yeah.
And at that point I was the technical business development manager for wireless. So I worked with the first two launches, the Pocket PC. I moved out here initially about 5 years ago with the Wireless Telephony Group Europe, and I oversaw a group that was responsible for the technical relationships for OEM and handset vendors that were taking Microsoft Mobile Explorer and taking that source and porting it to their chipset with their compilers, and being able to utilize that on what was called feature phones. Okay. At that point we had feature phones, the lower end phone, what I would call a Pocket and an Explorer. We also had the higher end smartphone, and then the Pocket PC phone edition. And we, at that point, there was a decision to focus just on the Pocket PC and the smartphone. Hello, Dr. Black. All right, thanks. We'll...
hold on a second. Sorry, we just cut off while you were on the phone. So that was Richard Black, you said? Or?
Yeah, you'll be meeting with Dr. Black next. Richard was one of the primary principal researchers on a project called Topology Discovery. And I really enjoy watching people's eyes on this particular demonstration because effectively we all know how complicated a network could be at home. It could include wireless access points, several computers on a LAN. And when things go wrong, it's often difficult to troubleshoot, where the bottleneck was, or what connection actually went down. Richard is able to actually have some master and slave, research software that's installed, and it will actually pictorially be able to represent and show you exactly what the state of your network is. Okay. So if you unplug a network connection, you'll actually see this. And it's quite an interesting demo, and something we're proud of that will be included in future versions of Windows.
All right. So what's it like working here in Cambridge versus Redmond?
Well, there's pros and cons to everything. I would have to say that, if anything, there's a mentality in Redmond that, working in Europe must be a lot more relaxed. That's definitely not the case, because I generally still get in at a normal, 9-ish time, but the conference calls in Redmond don't really start until 4 or 5, so generally I feel like I actually work a little longer than I did in Redmond.
I totally, since being here this weekend, I can totally feel that, because I'm talking to people at 2 in the morning, because of the time zone, and they're all working there, and you want to be involved, and
exactly.
It's
yeah, you want to be involved. You want to stay involved, and if anything, part of my team is responsible for technology transfer, research strategy recommendations to the directors here, and incubation. And as far as being able to stay on top of it, you have to also be building a relationship of trust with the product groups, and you have to stay in touch. Yeah. I'm off in Redmond, I'd say about every 7-8 weeks for a week, and it's important to actually stay in touch with folks, even when you're not in Redmond. So that definitely means staying on the phone quite often.
Now, are there specific areas of research? Like you mentioned, you were in the mobile division, right? And I would expect mobile, just reading the papers here, mobile is culturally much bigger here than in the United States.
I think it's a hotbed here as far as, gosh, when I came here, SMS messaging was something that was, widely used already. Yeah. And I know that's something that's just now really getting, a good foothold in the United States. Yeah, but we don't, like here I was watching TV and they said to buy tickets, send a text message for the latest concert, or if you want to support the Olympic bid for London here, text a certain address. And we don't use that term over in the United States that way. This was on the front page of the newspaper. No, it's standard. It's something, when it comes down to it, everybody has a phone these days. A mobile phone, that is. In fact, I'd say that quite a few folks that I know here don't even have a landline. just a mobile phone. And once everybody has a phone, it's quite easy to send a text.
Yeah. So what I also saw in the lobby here, posters for Forza, for the Xbox game. Are you guys doing research here for that?
Yes, actually, after you meet with Richard, you're going to meet with two other researchers in the machine learning. At one point that was called artificial intelligence, but these particular two researchers, Ralf and Thore, were the brains behind the math that enables a more compelling matchmaking, shall we say, when you're playing Halo 2. You're able to have a more competitive experience in that it will be able to assess and address what your skills are, what your true skill is, and that's actually what they trademarked, the name's true skill now, and be able to get people to have a competitive experience. When it comes down to it, if you're having a competitive, compelling experience, you want to play the game more and more. There's other researchers that actually did the drive-atar functionality in Forza, the ability to actually race against yourself or race against somebody else, but actually being able to model the way somebody really does drive. And it's actually kind of interesting to race against yourself.
Well, cool. Well, anything else you want to tell me before we start taking the tour of all the labs?
Not really. There's a couple of folks that we wanted to set up for you to see. Richard will be showing you topology discovery. Ralf and Thore will be showing you the true skill, what they did with the Halo 2, and actually it's for Xbox Live that we launched with. That was something that was shown most recently at E3. I just came back from Los Angeles. That was 2 weeks ago.
Yeah.
You'll be meeting with Karsten about the tapestry I've mentioned. You'll be meeting with Ken Wood and several of his folks in his area, and Luca. I know you'll also be meeting with Peter Key, who Richard reports to. Peter Key's one of the directors in networking research.
Okay.
But yeah, why don't we get you down to see Richard first.
Great.
Director of the lab.
Hey, how you doing?
Robert.
And who are you?
I'm Andrew Helm. I'm the lab director.
You're the lab director.
Hi, good to meet you.
So we're from Channel 9. I don't know if you've seen that back in Redmond.
Absolutely.
And
it's a great show.
We're just getting a tour of Cambridge while I'm on vacation here. So
It's a good first day back at the office for Mitch.
Absolutely.
So
How are you enjoying the beautiful Cambridge summer weather?
This is great. This is summer weather. It's better than Seattle was when I left.
You bet.
So what do you do here?
So I'm the lab director.
Okay.
So my job is to make sure the lab as a whole works pretty well. I guess Mitch has told you we've got 4 research groups. My interests from a research perspective are kind of more aligned with operating systems and networking. But the great thing about being a lab director is also get to learn about machine learning, information retrieval, programming languages, the computer mediated living group. It's great fun stuff. So kind of jack of all trades and master of none, I guess.
Excellent. So we're getting a tour, so we'll see you later.
Okay, enjoy the rest of the tour. Good to talk to you.
Thank you.
And enjoy the rest of your vacation.
Thanks. So it's a beautiful office here.
Yeah, the campus, you can see one of the tall buildings there. It's really that close.
That's Cambridge University there?
Yes. Richard, I already forgot his phone number.
I'm going to turn off here for a second. Hey, how are you doing?
Hi.
I'm Robert Scoble. How are you doing?
I'm going to leave you too.
Great.
And if you want to give me a call, I don't mind coming back down.
Sure. Okay.
Computer should be available.
So who are you? That's my favorite question.
All right.
So start out.
I'm Richard Black. I've been with Microsoft about almost 5.5 years now.
Wow.
And I was previously at a lecturer at Glasgow University in England, or Scotland, sorry, in the UK. And my speciality is networking and operating systems. I like to look at any issue where networking impacts operating systems or vice versa, so kind of the interaction on the edge.
So are you working on the next version of Windows right now? The Longhorn?
I have some technology I did in the last couple of years, which looks like it's going to be in the next version of Windows and Longhorn, yeah.
Excellent.
So I've been helping the product groups understand, get to grips with that.
Very cool. Well, we probably can't talk too much about that today, but
well, I can actually.
Oh, you can?
Yeah, it was.
The PR teams are like,
No. All the academic research was published last year.
Okay.
And the technology demo was shown at WinHack this year.
And what does it
the
do?
OEMs have already got all of the relevant, SDKs.
So your work is already in the WinHack build that was handled?
No, it's not in the WinHack build.
Okay.
It probably won't actually be in release builds until Beta 2.
Okay.
But
Which is next year.
It was shown at WinHack.
And what does it do in a sense?
Basically, it's designed for home networks or small companies. So anywhere where you don't have like a professional IT staff. And
Let me go in here because the lighting's a little bit better.
Networking problems are really hard for people to diagnose and understand.
Right.
Something goes wrong, they can't get their email, and they don't know whether it's is it their local machine, is it their email app, is there something wrong with their network cable, is there something wrong with some piece of network infrastructure, is there something wrong with the server, is it their ISP? It's very difficult for them to diagnose. Also, it's very, very difficult for, let's say, a telephone support person to work out what does the user's network look like, what should it look like, what's the differences, which bits are working or not working today, and all those kinds of things. So basically, the technology that we have is designed to help with that problem.
Yeah, I'm having a problem with my son. He lives in California, and I'm in Redmond.
Okay.
And I can't use the MSN Messenger's audio.
Right.
I get video, but no audio.
Right.
Which,
okay.
So this technology is going to be useful for me?
Perhaps. It's a little different because that's a wide area networking problem. This is looking specifically at the local area.
Ah, okay.
Because there was no research previously looking specifically at the local area. And everything that's been done in the local area before now has focused on basically using SNMP. And SNMP assumes that you've got big enterprise manageable switches, which of course in the home of a small area and small business you don't have. So that's no good. So what we've done is a technology which you add a small responder component to all the Windows PCs around the edge of the network, and then whenever you go to basically try and map the network, what happens is your PC contacts all of the responders that it can find, and it coordinates them to probe and analyze the network, and then as a result of that it works out what shape the network is. So it finds all of the Ethernet switches and the hubs and the access points and so on in the network, and works out which machines are connected to which and how they're interconnected.
Right.
So I can show you a demo here.
Oh, cool.
Looking at my local test network. Now this is just a prototype, okay, so this is going to look pretty ugly.
Oh, that's fine. We're used to ugliness in Channel 9.
So this is networking research, and when of course the product groups will do a proper UI on this.
Yeah.
So I'm select the network interface here that's on my test network, right? And when I click map here, it says it's discovering hosts, and it found 11 hosts there. And it takes a few seconds then to get them to probe and analyze the network. And then it comes back and shows me, well, that's what my network looks like. So these are all the actual machines on my network, and you can see all of the Ethernet switches that are on here. And it's capable of working out how they're all interconnected. And for some topologies, it can also find, even if you've got Ethernet switches that don't have any computers attached, they only interconnect other Ethernet switches, they can still find where they are and work out where they are
Now,
on the
how
network.
does that work?
Oh, well, that's...
I mean, if I have a hub and a switch and how does it sense that? How does it know that?
Well, basically, it relies on something very fundamental to do with the way that Ethernet works, and that makes it extremely robust to changes in technology, to new technology. An Ethernet switch works by learning MAC addresses. When it sees a packet from some particular machine, it learns that that machine is attached to a particular port. And so after that point, if it sees a packet with that as a destination, it knows to send it to just that port. And if it doesn't know where some destination is, well, then it just floods it. Okay, until eventually it sees a response and works out where the machines are on the network. So basically what we do is, using the responders that are positioned all around the network, we very carefully and in a cunning manner introduce some new Ethernet addresses into the network and observe when the switches go from not knowing about them to knowing about them. And that tells us exactly what shape the network is.
Wow. So I imagine this kind of technology would be used like in a small business server package to help small business people build the network. Now, can you put suggestions for improvements to be made to the network as well? Like if you have a hub that's not very fast.
There's lots and lots of things you can do once you've got that. I mean, in terms of what's research and what's product development. Okay, well, research is, can you work out what the shape of the network is, right? Yeah. And yes, you can with some particular cases. And then, of course, how do you do that into products? Well, the product script's going to do a whole pile of different things. Some of the things you can do, we can do bandwidth analysis, right? Anytime you want to understand where's the performance bottleneck in my network and that kind of thing, well, it helps enormously if you know what shape the network is to start with.
Yeah.
Right? And then you can analyze each of the individual links, work out exactly where the bottleneck is, which device is bottlenecked, or which link is bottlenecked. All those kind of recommendations of how to improve the performance of my network are much easier once you know what shape it actually is.
Yeah.
But you can do a whole. So, for example, let me see, something like eHome. If you've got a Windows Media Center server in your home and you're streaming some video around and things like that, you want to understand, well, why can't I get an extra video stream through? And it's going to say, well, because maybe you've got this 10 meg link here, you need to go upgrade it, or maybe you've only got an 802.11b access point. That's an 802.11b access point, and that this laptop's associated with the 11b access point, whereas that laptop is associated with this 11G access point, and that's why you can get video here and you can't there, and all those kinds of explanations. Or if something goes wrong, something gets unplugged, it's much easier for the user to see, well, here's this bit of network that's just grayed out, right? It's disappeared off. That's why I'm not getting the connectivity that I expect. All this kinds of diagnostics, network troubleshooting, automatically making information about the shape of the network, the bottlenecks in the network, how much video you can get across the network available to applications, video servers, all those kinds of things.
Now, can you build new applications using this data? Like BitTorrent is one I use, which is a P2P video and audio sharing program.
We're going slightly into the realm of things that I can't talk about.
Okay. All right.
Let me just say that obviously, if you're going to be sharing some content in the local area, it's much better if you get the content. If you've got like 3 or 4 people on a large network who have the content you want, it's much better to get it from somebody closer to you, right? Yeah. Or somebody who has a higher bandwidth path to you than somebody else. So all of those kinds of things, you immediately you have the fundamental research information, which is what shapes your network. Then, a whole pile of things, cool technologies, new applications will become available. You can make the experience, both new applications and the existing experience, just so much better for the user.
This is great stuff. Well, anything else that you want to show us on this technology? This is really neat. A lot of people won't be able to see right away what this will let product teams do down the line, but I get it right away because of the BitTorrent problem of, if you have 3 machines sharing, where is the best place to get that file? This is good stuff. Okay,
so just remember this is a local area technology.
Yeah.
Now, of course, there's lots of other techniques that exist in the literature or in products for working on wider scale topology analysis. And the way to think about that is, well, this is how you do the drill down on each individual Ethernet within a larger network.
Yeah. Great stuff. So what have you learned by playing with this? Have you come up with any new laws, or any breakthrough thinking on learning how Ethernet networks work?
Oh yeah, I've discovered a lot of bugs in a lot of bits of Ethernet kit. So, for example, right at the outset, when you first click map, one of the things this does is it does some very carefully constructed packet sequences to look for some particular chips that are really, really buggy. And if it finds them on the network, it just says to the user, "I'm sorry, but you've got a particular chip, and your network is just in a bad way, and you need to go through that box away and replace it." So you find all kinds of when you do a very careful analysis of exactly what is the Ethernet switch doing in terms of packet routing. And then you discover that some existing Ethernet switches have got really bad behavior, which can cause all kinds of intermittent problems for a real user. But for us, we can just find it like that, and then put up a dialog box that says, "Sorry, you've got a
bad box.
You need to go replace it."
Wow.
So you find out a lot of things like that.
How did you get into networking? What interested you about this field of research?
Computer networking in general?
Yeah.
I got into computer networking age 13 when my school got a very early network from a company called Research Machines, a British company. And that time they were using CPNet, which was a networked version of CPM, on some Z80 boxes. And I really got into networking in a big way, starting right then, looking at just extra good things that you can do once you start connecting computers together.
Wow. And how long ago was that?
That was 22 years ago.
Wow. Got into it, yeah. Anything else you want to tell us about what it's like to work here in Cambridge? We're here from Redmond. This is our first trip abroad. And
oh, it's great working here. Yeah, no, it's a really good environment. We have a lot of academic freedom to do a lot of really good breakthrough blue skies research, and at the same time, you look for opportunities of things that you can do that are useful for the product groups.
Yeah.
And this is an example. I've done some other stuff which isn't so graphic or easy to explain or easy to get across, but which is also useful.
What kind of stuff?
So. Oh, I've done various stuff on. I mentioned bandwidth probing stuff. I've done some work there. I've done some work with quality of service and.
That's really important for video.
Improving the network experience on the last mile.
Okay.
And some stuff like that. But this is nice and graphic. It's easy for people to understand.
Yeah. Well, this is great stuff. Thank you for showing us.
No problem.
Thanks.
Thank you for coming by.
Yeah. The future of networking.
Okay, which one of these mice belongs to this?
So we're back with Richard. This is his little lab out in up in space here, and he has different colored Ethernet cables, so you can keep track of what pieces go into the network. And what are you going to be showing us here?
I'm just going to show you the same thing, except I'm going to show you the differences as I change the cabling.
Okay.
But I'm going to type my password, so you probably want to.
Well, you can't see it anyways,
Okay.
so I'll look away. Cool. Yeah, we're getting flicker on that screen, so probably let me stop this right now.
This is Ralf.
Okay.
He's going to tell you about lots of fun Xbox things.
Ah.
Yeah.
Explain.
Hello. Okay.
Thanks, Richard.
Okay.
That explains the Halo 2.
Alright as well.
Do you have lights in your office here?
Yeah.
Oh, great, thanks. I always have to turn them on. I'm Robert Scoville. How are you doing?
I'm fine.
And who are you?
I'm Ralf Herbrich.
And what do you do here?
We work on games. I just got my colleague come over, so we
Alright.
work quite close together.
Hello,
Hey, how
I'm
you
the
doing?
colleague.
What's your name?
Thore Graepel.
Great. And you guys work on games.
Yeah.
Now my son got a tour of the Xbox division back in Redmond. He thought it was the coolest thing. He said, these people play games all day long. And I go, no, that's not really how it works.
That's
right?
exactly what
That's in fact, we already prepared the
Oh,
games
don't tell my
for
son
you.
that, you know.
Let's go, we show you our
Yeah,
games.
we show you a games room first.
Let's go.
This is what
Of course,
motivated,
we only play after lunch.
and that's what actually motivated our latest research. You can see right now.
Okay. Can you turn on the lights? Is that possible?
Okay.
And looks like the refresh rate is good. Great.
You see, obviously, the best game in the world, Halo
Yeah.
2 here.
Okay.
Our lunchtime favorite.
Exactly. So let's just go in. So actually, to just tell you what we're doing, let's choose the Rumble Pit Hopper. So the game that we're doing right now, because we played many games, there were
Yeah.
many lunches, it already knows that we are skill level, this is a test account of ours, skill level 13. So what it tries now is to say we want to play a game, but basically it's searching right now who is playing and who's around level 13.
Yep.
Because the assumption being if you play level 13 people, that's going to be the most fun for us. Well, there they are.
Great.
So you will see.
Now, obviously, we're much better than level 13, so this
Yeah.
motivated us to improve the ranking system, right? Obviously, it gets us wrong, because there are 50 skill levels, and we cannot just be level 13, right?
Right.
Precisely.
So,
So that's what triggered it. We played it at lunchtime, and we thought we're much better. The algorithm's just not knowing it yet.
Yep.
So I don't know if you played Halo 2 before or not.
Oh, yeah.
Let's see if you can remember the skill. Think you're gonna die?
Somebody got it.
So
see,
So
we
you
always
take this in
switch
turn.
pads here, so this is really our average rating.
Yeah, you killed him. Good. Did you get the kill on the camera?
Yep, I think so. Oh, they got you.
Yeah.
Well, actually, what we found is that we aren't much better.
There's some really good guys who work over on the Visual Studio. So what part of this did you guys write?
We can show you this in the office. But let's get one more kill in. Then we go over. Shall we? Or do you want to continue?
No, we continue. This is fun.
Well, in the office, I mean.
So you see the game when the game finishes. I don't know. This is going to be another 3 to 4 minutes.
Yeah.
We could wait for it. Let me just turn it down a bit.
All right.
What do you mean down?
You guys have too much fun over here.
Yeah. So when the game finishes, it'll basically, we're going to be at some point. Right now we are. If you have a look, we are second already with 5 kills. Right.
Okay.
Hopefully we are still second at the end of the game, or even first. So then it knows, because we'll be playing level 13 and level 14 guys.
Yep.
And it knows that we must be a bit better because we killed a couple of level 14 guys, hopefully. So there's an algorithm that basically takes into account what was my standing before the game, what was the game thinking up front about my skill, what was the outcome of the game, how likely was it, what updates do I need to do. In a nutshell, if I was ranked too low, I should go up a bit. If I ranked too high, I should go down a bit. Now the Halo, one feature that our new ranking algorithm has, it tracks not only what is your skill, but how much the system knows about your skill. So if you only played ever one game, it knows very little, so it can move in big steps. But let's say you played 150 games, so it pretty much has your skill down, and you still lost the game, then that's purely due to random chance, and not because the system is so uncertain about your skill. So by tracking the uncertainty in the estimate of your skill over time, it can actually be much better. It learns much faster in the beginning, and once it pinpoints you down, it basically stays there. So it's much fairer to the gamer.
Yeah.
So we have done experiments on the Halo 2 data actually. I can show you some later. And in a game like this, 8 people played out against each other, called Rumble Pit Hopper. We're looking at 20 games per player, and then the system would know pretty precisely what his skill is. So right now, people have to play hundreds of games. So with our system, after 20 games, the system would know your skill.
The problem is, if the system doesn't know your skill, it matches you with people, and it's absolutely no fun for you to play, because they're either much better, in which case you lose, or they're much weaker, in which case there's no challenge.
Yeah.
And the quicker we can find out a player's strength, the faster he can have fun games. And so that's the goal, making it more fun, right?
This is awesome. So how did you guys get into this?
Well,
do you go to school and say, I want to work on games?
So the story is, our group was set up 4 years ago. Some of us, we had a big brainstorming session at the time, and we were thinking, what can we do with machine learning? Because we were pretty theoretical and non-applied. And one of the ideas we had was to say, well, let's apply machine learning to games. So the first project we've done for the last 2.5 years was working with racing studios on Forza Motorsport. So the driver feature in there that's what we developed here and designed and developed. So then in the end, when the project was coming to an end, the Forza project, we were participating in the Halo 2 beta, which happened last July. And so we were actually exposed to the problem, as it were. And we just had this idea. So I remember one morning, all of us coming in saying, look, I'm going to be funny, but I think we're much better. We got to work on this. We got to try to improve this. So that triggered it really, and then we asked Bungie, very nice people, if they could give us data and that we can confirm our hypothesis.
Also, it's much better to work on your favorite game than on any other game, right?
Yeah.
So actually, we can say that our lunchtime sessions are work because we're testing the system.
Yeah,
that's pretty useful.
Yeah.
And what was useful as well is when Bungie gave us the data and the beta data, and we could rank it. We obviously looked at ourselves, right? And we knew how good we were, the 3 of us, relative to each other. And that was just convincing to us as well. We knew we were right because we knew our 3 skills were estimated right.
Yeah.
So we've given a TechFest talk about this for people who are interested.
That's for employees.
That's for
only.
employees. Sorry, that's for employees only. Yeah.
So this goes on the outside world.
Oh.
So this is great stuff. You guys get to play video games during the lunch breaks. So.
Yeah.
Have you learned anything surprising by doing this that you might not have expected?
One thing we found out was that the old system has really a bias towards playing a lot. People who play a lot are considered higher ranked by the system. And that's just not always true, right? I mean, sometimes they're just very skilled people who don't play as much, and sometimes it's true, obviously, if you play more, that's good. So the Halo system had identified a certain character as the best player.
Have a look. So this is the final standing. Sorry for interrupting, but that gives the idea. So the game finished. There's like 7 people participating.
Yeah.
And right now it knows the level 13 guys beat the level 14 guys. So obviously there's still a little mistake, right?
Yeah.
So all these 13s, including us, which became third, will go up a little bit because we beat a 13 and 3 14s.
Right.
So that's what we basically changed. The way that the game takes this into account. The way that the ranking system takes that into account. Sort of reads off what is the skill before the game, what is the final standing, in our case third. So we got to make a little adaptation, and it's doing that.
So you're going to be moving up in the world after this lunch, right?
Well, not with the Halo 2 system, but
yeah.
with our system. But given the number of games we put in already, I don't think we would move any longer.
Right.
Yeah, I was just saying, you were asking for a surprise that we found.
Yeah.
So the leaderboard was led by someone who played a lot. It turned out to be the son of a sequel developer, actually.
Yeah.
And
it's funny how all the Microsoft employees had a little edge there.
But then in our system, that guy didn't come first, but another guy came first, and then
this guy's known actually. So
Char, his name is Char,
right.
And. Then we looked at the data, and at some point they actually played against each other, and it came out, yes, Char is indeed the better player, and the system had correctly identified.
In fact, the system had even identified a fraction of winning roughly right, so he won about 60% of the time. The system predicted something between 50 and 60%, so it was quite reassuring that the system knows a little bit about the strengths of each of the 2 players. And that means, of course, that it knows about the strengths of everyone.
Is there any way to game this system? Because I really suck.
Yeah, know the inventors.
Do you guys take bribes?
Yeah.
Yes, we do.
Yeah. You do take bribes. Uh-oh. Anything else that you could tell us about what it's like to work here in Cambridge, and particularly with the Xbox or the Forza teams? Now, Forza is not a Microsoft game, right?
Microsoft is Forza, yeah.
Oh,
sorry, Forza is a Microsoft game.
It is, okay.
Yeah.
I thought it was developed by an outside lab.
Well, lately we've got this cool booth. I think you've seen that one, right?
Yeah.
So with the racing seat, 3 plasma panels. That's fun too, that we can actually, get our hands on the real thing. Not just one TV and an Xbox controller, but the real.
Yeah.
So in general about this place, the nice thing is it's not too big, so most people know each other. It has a relatively relaxed atmosphere, so people are left alone to work on what they want to work on, and that's usually a really good idea because that's what they're best at if they're at maximum motivation, so to speak.
Yeah.
And then we have to strike a balance between academic work and practical work. So it's fine if someone focuses on academic stuff, but maybe it should be useful every now and then, or other people focus on practical stuff, but there should be some academic value in it as well. And in this project, that's kind of covering both. So we're transferring it as a product now, but it's also really state-of-the-art in statistics. So later on, when the smoke has cleared, we'll publish stuff in academic journals and stuff, to let other people know about it.
What's the relationship with the local colleges here, universities? Cambridge University and the other universities?
I happen to be actually very closely related because I was a fellow of the Darwin College for 3 years. And I think the kind of summarized relationship, what we do a lot is we supervise PhD students. In fact, right now, a PhD student is currently an intern with us, and we 3 are working on Go. I had supervised the PhD student from the engineering department. So that's the level of, that's kind of the interaction. We don't teach at the university, but we do take students and co-supervise them through their thesis.
You might have noticed that the building opposite the computer science building, computer lab building, is called William Gates Building. And that's apparently named after Bill Gates' father, is it?
Yeah,
yeah.
That's right. That's the way.
Because, money changed hands.
Yeah, no, he gives a lot of money to colleges. I know
Yeah.
Stanford has a William Gates building as well. So,
but it is encouraged that we do collaborate with the university.
Yeah.
There's even workshops in other areas, not so much in the games areas, not so many games group.
And as you can imagine, Cambridge is a fantastic environment for that. I mean, you can, if you look for them, there's great people to work with here. And that's really easy. I mean, sometimes, if it's a project that has commercial implications, then you have to be careful and work out the legal implications beforehand, because otherwise things can get messy in the end when there's a good result and people don't know whom it belongs to, or if it should be published or patented and stuff like that. But this can be worked out beforehand, before you start, and then things are great.
Yeah. Well, cool stuff.
Cool.
I'm glad to see somebody who's working on Xbox 360 and get a little look at inside the technology. We're supposedly getting a tour of the Xbox 360 group soon. So.
Ah, cool.
So
that's over in MGS, I guess.
Yeah, back in Redmond, I guess. They've been really busy doing all the launch stuff. So. They're like, what? Channel 9? You come after all the video game magazines.
They're very nice guys. We work with the live team there quite closely, actually, on that one.
So do you play with Larry Herb or?
No, Major Nelson. You mean?
Major Nelson, yeah.
No, I haven't played with them. We work with Pedrick O'Kelly's group and Jerry Johnson's team. Okay. So. But we haven't played them yet.
Yeah, well,
played the rare guys a bit.
I'm sure he's online once in a while. So. Well, thanks.
Sure.
So who's next?
If only you knew that.
Who's next?
Carsten Rota. Yeah. Not right now. But I guess he's just getting lunch.
Just getting lunch. Okay.
Hey, I'm Robert Scoble. How are you doing?
Peter Key.
And who are you?
I'm Peter Key.
Peter Key.
Actually, just before we start, where's your schedule today?
We're here in Cambridge visiting, and who are you?
I'm Peter Key.
And what do you do?
I head up the network and systems and networking area, research area here in Cambridge.
And actually, let me change shapes. Hold on just a second.
I'm Peter Key, and I head up the systems and networking research area here. There's about 20 of us working across the whole area of systems and networks. And
I guess this is the research lab here.
That's right.
Beautiful
that's
new building.
Out in
These are what, 2 or 3 years old now?
Yeah, something like 3 years old. That's right.
The Cambridge University is right across the way there?
That's right. So across there you can see the William Gates building, and that's where the computer lab of the university is.
Well, that's convenient. Recruiting is pretty easy, huh?
Absolutely.
Just got to walk in. Hey, we need a new researcher. Let's just walk across and see if we can hire somebody.
Yeah, that's right.
And so what do you do?
So we look at all aspects of systems and networks, from very small. What can you do to improve even a single process, single computer? What can you do about, for example, memory, or how can you avoid locking problems even within a computer? Right to the other end of this scale, what can you do if you've got large peer-to-peer networks, hundreds of thousands of nodes? How can you create distributed applications? So we kind of look right across that space, very broad, and lots of different areas. And I guess we're a mix of different people as well.
Very cool. How does Microsoft decide to do research here rather than in Redmond or San Francisco or China?
So it's very much bottom up. There's no top-down direction to research funding or research direction. It's very much the researchers decide what they want to work on, more or less, propose projects, and get enough critical mass to decide to work on it. So that was an example of this file swarming. We got interested in it. It seemed an interesting problem, and other people got interested in it, and people came from all sorts of different angles and then tried to create... so we were looking at it from a theoretical angle, how do these systems scale, and then from the practical angle, how can you build these systems? And again, that was a good example. We had an intern come again who was interested in working on that. We had a couple of interns, and they're involved in developing the system.
Now, since the university is so close, right across the street there, how does the research work with the university here?
So we have good relations with the university, but it's very much, again, it tends to be people-driven. So people here know people in the university and they want to work with them, then research happens. But there's not a prescriptive fiat that says you shall work with them. It's where there's mutual interest, when it's benefit to both parties really to work together. So that's what guides it very much.
Yeah.
But obviously there's close links. There's close personal links. There's certainly a number of people in this area, my area, in systems and networking, have come from the computer lab. So there's no people there. It's social contacts. There's always social contacts that often drives the research agenda. So they know people, they work with them, and that drives the whole process.
Do you guys do joint events, parties or geek dinners or anything like that?
Not very often. We invite them to our kind of social events, and we sometimes have a joint conference, but and we have joints. When they have seminars, we go to their seminars, they go to our seminars. It's that kind of level of interaction.
Very cool. Well, who else are we meeting today?
So we can go upstairs and see some of the people in the as they sort it, computer-mediated learning. It's just been renamed. You might think of it as something like HCI.
or we can go and look at some people in programming language, or some people concerned with worms. So it's up to you.
That's too much to choose from. HCI sounds like, or computer mediated learning sounds interesting. Because we've met the programming languages folks from
before.
Cambridge.
Okay, fine. So let's meet the other team.
So what else is fun to do in Cambridge? Since a lot of people will be watching this around the world. There's some beautiful churches, look like churches, right?
That's right, beautiful buildings. It's a very ancient university town. There are lots of colleges, lots of student life.
Now, when you say ancient, how ancient is it?
Well, at least 450 years, 500 years plus.
That's some, I grew up in Silicon Valley, and there's nothing there that's older than seemingly 30 or 40 years.
So I'm actually from the other place. I'm from Oxford, so I can't tell you exactly how old Cambridge is, because I think it's younger, but they would dispute that.
So you went to Oxford?
I went to Oxford, yes.
And how do the two towns compare?
So Cambridge has got the backs running through, the river running past the colleges. That's a nice feature. Oxford's got more of a town. It's more of a town or a city in its own right than Cambridge, where the university is a very big part of the town.
Right.
So yeah, fun things to do. Obviously, it's nice to go punting on the river here.
Now, punting is what?
So punting is on a boat where you propel yourself with a pole.
And that's the punt?
That's the pole's a punt, and the pole is called the punt pole.
The punt pole. I read about that on the internet, and my friend Buzz Bruggeman, who's CEO of ActiveWords, told me you got to go punting on the cam. So we'll see if we can work that out.
Bring a camera.
Yeah.
I was told that you weren't going to bring one. Hi there.
How you doing? So you're Ken Wood.
I am. Peter, I was told that after seeing my group that Robert would be coming back to you. Is that right? Or?
Yeah.
Okay.
That's fine, because at 3 I'll take him, give him over to Austin, and he'll take him punting. So.
Oh, cool.
Great.
And if he wants to see Manuel Costa before, then that's up to him on Vigilante. Otherwise, he's up with you the whole time.
Okay.
Or with
We'll
Costa.
just play it by ear then.
Yeah,
Thanks.
sure.
Great. So you're Ken Wood.
I'm Ken Wood. That's
So I don't have to ask you who you are. And what do you do?
I run the recently renamed Computer Mediated Living Group.
And what the heck does that do?
Yeah, exactly. I've actually taken. I don't know what. This is actually going to be a Channel 9 thing, and I hope not.
Oh,
But
so
it's in fact, I did. There was a Channel 9 interview with me last year about what was then what we were just after it was formed. We were calling the Interactive Systems Group. But we basically decided after.
Yeah, Mike Hall was out here, right?
Exactly. Yeah, and so Mike saw me, and we talked about that. And so the group's remit hasn't changed that much; just the name has. We figured the name Computer Mediated Living reflects a little more about what we do overall as a group.
And what do you guys do?
Well, one of the reasons, for instance, that we wanted the word living in there was just to have a slightly softer word. A lot of the MSR groups, are very technically focused and have very technical names. And in my group, we have sociologists and psychologists on staff, as well as hardware engineers and computer scientists. And so we're interested in sort of rigorously looking at the human side of things. Right? So really using sociological analysis and psychological analysis to work out what types of things we should be doing with technology, and then B, how best to do them. And then because we still do have hardware engineers and computer scientists, the idea is to, based on that input from the social sciences, design and build new things, and then put them out in the wild, actually give them to people in the real world, test them out, and get into sort of a feedback cycle where we see, well now, was our social analysis right in the first place? Was this a good idea? If not, how should we change it? And get into a sort of design loop that way. And really looking beyond the sort of, sitting at your desk in your office sort of computing. Because, another possible umbrella name for the group was going to be human-computer interaction, but that tends to have quite a narrow interpretation of being just about sitting in front of a monitor and how do you optimize that. Right. Whereas we're about a much broader range of things.
So what fields are you studying? How humans interact with machines, like on a factory floor, or are you doing mobile computing?
Yeah, it's more mobile, ubiquitous computing and communication type thing. So I can give you one example. Is that one of the sociologists in the group has done a lot of work analyzing text messaging and why the take-up of text messaging has been so incredibly vast. And so based on that, we've decided to explore the notion of texting to place as opposed to just texting sort of person to person. So we built this thing which we call Home Note, which is just a very simple situated display that sits in your kitchen or on your hallway table and doesn't do much other than let you text message to it. But the idea is that members of the family can send text that will show up either on the hallway table or in the kitchen, and that way they're at once addressing A, likely only members of the family or very close friends, and B, people they know are in the house at the time. And so we've kind of put this out here. There's 5 households in Cambridge now that we've installed these in, and they're going to spend about a month using them, and we're going to tease out, how this may or may not be beneficial, how we might modify, what features we might want to add to make it a more useful product. So
texting is a lot bigger here than in the United States, at least culturally. I mean, I was talking with another person downstairs that the front page of the London papers have texting in headlines.
Oh yeah,
like
it's
supports the Olympic
popular.
to text this number, and stuff like that.
And there's many programs here now. You can vote for things by texting in. And it really is extremely popular here. And I mean, I shouldn't really be talking too much more about this because Richard Harper, who's one of the sociologists in our group, is a real expert on the sociology of text messaging. You should really talk to him because he's done a lot of work on analyzing the success of text messaging in the guise of analyzing text messages as gifts in the real sort of sociological sense of gifts. And so, I shouldn't say too much more about that, but you could talk to him about that.
Oh, I'd love to. Are you working with the Virtual Earth people to figure out how to put text onto maps? Like, I don't know if you've seen the Virtual Earth stuff.
Yeah, I've seen that. We're not working with them particularly, no. Although there is some work going on in the group to do with using location derived from cell phone information to do. I mean, a lot of us in this group have a history of some of the earlier location technology work with active badges and active bats when we were at either Xerox or AT&T. And we're kind of revisiting that, thinking that with cell phones, pretty much everybody there's 650 million cell phones sold last year. So a large fraction of the global population is carrying around this little tiny device, which can be used to locate them to a relatively coarse-grained scale. So we also want to explore that notion. What could we do with coarse-grained location information that would be useful without being intrusive? Right. So maybe a very simple. I mean, you've probably seen the Harry Potter movies that have this clock where there are hands corresponding to the family members, and the hands point to these rough directions to indicate where the family member currently is. And we've been thinking about the fact that the granularity of location information you get from cell phones could let you implement pretty much exactly that. So that's another thing which we're in the process of developing to do the same kind of trials that I said. So that we're going to give this to families and just see how they get on with it. So,
wow, that's a lot of fun.
It is actually a lot of fun. That's I guess I should have pointed out too, if we're on names, just because I may get some pushback on this, is that computer mediated living is the blanket name for my sort of patch of the lab, as it were. But most of what I've talked about just now comes under the subheading of socio-digital systems, which is the name of the group that's really doing most of that work. And the idea being to sort of combine, social science analysis and digital systems development to and sort of marry those up in a nice interdisciplinary way.
Right. Now, yesterday I got a tour of the Microsoft Home in London. Do you work with them at all?
Yeah, well, no, in fact, I would have loved to have been there, because in that case, you probably met a lot of people from my group, because several of them were there.
Oh, really?
Were there yesterday.
I don't think I did.
What time was
Cynthia
your tour?
gave me a tour. So.
Oh, okay. So, because I was in touch with Cynthia, and I was going to go, but I couldn't for various reasons. But a lot of people from my group went. So I guess the answer is I'm aware of that work. And I've been talking with Cynthia about the possibility of working together, but we're not doing so yet.
Okay.
But the thing is, I'm also in regular touch with the people that run the Microsoft Home in Redmond as well, and we are actually working with them. So it would make sense for us to work with the people closer to home as well.
Oh, very cool. They had a kitchen with a tablet PC set up, and talked about some of the scenarios there. So that sort of fit my mental image when you say that.
Yeah. Well, what's actually funny is that the way that we wanted to implement these home note devices relatively quickly, so we essentially put a nice looking case around a tablet PC. So in fact, our home note devices are tablet PCs in the kitchen, but with intentionally reduced functionality to just explore this kind of one notion of texting to place, rather than suddenly sort of exposing all the other things which you could do with a tablet PC in the kitchen. But we want to gradually sort of unveil those as it seems necessary or interesting.
Right. Are you doing any research with kids or playing with the computer? I know that over at Microsoft Research I saw a play table, which was really cool.
It's
I don't know
very
if you've
cool.
seen it.
Yeah, I've seen it. Yeah. That's a very, very good
And
thing.
we'll have a video of that separately. But
Oh, excellent! Yeah, because Dave Kurlander, who's sort of in charge of that, is an old friend of mine. I've seen that since sort of early days, and it's just fantastic.
Yeah, it's a lot of fun to play with. Just simply, you have a table with a video projector underneath with two cameras, right?
Yeah.
And on the surface, he hands you a bunch of glass chips, or what looks like glass chips. You look through them and you can't see anything on the chip. And you put a glass chip down on the table, and it starts playing a video on the chip. And it's just the most amazing thing I've ever seen.
I know.
It really has an invisible infrared pattern on the chip, and you turn the chip, and the video turns with the chip.
But also that you get 16 of those chips, and each one is playing a separate segment of the video, and you have to rebuild the video, right? Which is, and if you turn it over, I don't know if you notice, it actually inverts the video if you turn the chip over.
I didn't even know that.
So it's actually, it turns out even for a 4x4 sort of video puzzle like that, it's actually pretty hard, because if you have something like when I did it, what's the movie, Finding Nemo, the movie was playing, so there's all these colored fish moving, so each of these little squares of video has bits of color flying around it, and you can invert it either way. So it took me maybe longer than it should have to actually sort of assemble the video puzzle.
Right. But is that the kind of research that you're doing here, or is it?
No, we're more focused on the home generally. So we look at kids only insofar as they're part of the family structure, I suppose. We're not, we're working with a number of academic partners who are looking more specifically at applications for children. But it's not something which we're at least initially targeting here.
Right.
And it's still relatively early days here, but
what other things is your group doing that
gosh,
we might not know?
Kind of put me on the spot here. I thought that I wasn't really counting on this sort of interview, so. But I mean, there's a range of things. We're doing a project called Touch Talk, which is another mobile communications exploration that Richard Harper and Steve Hodges in the group are doing. And the idea there is to use mobile phones as a way of enabling simpler forms of communication, largely between couples or sort of pairs of people. So you would have some very simple device that might be on your keychain or something, that might be a little fuzzy bear or a little toy, and it would just do a number of very simple things. Maybe you could give it a little squeeze, and its paired up partner that your partner has would vibrate in a certain way or something. Just as a way of kind of tapping them on the shoulder electronically from a long way away. And the idea is to build a number of variants of that type of thing, and once again, trial them for real in the real world to see how that genre of communication might play out. And once again, given the incredible takeoff of text messaging, which on the face of it was a very simple form of communication, we're enthused and interested to see how this other form might take off. And we're actually doing that. I can't remember. Is the Channel 9 stuff internal only, or is
Nope, all external.
Okay, so we partnered with an external company to do this. I won't name it, but so this is this hopefully will lead to some interesting applications eventually.
Very cool. Well, are you going to give me a tour of anybody?
Yeah. Are you going to leave that on? Or
Yeah, let's go.
Okay.
It's the Channel 9 way.
Okay.
Somebody called me the public television station of Microsoft.
Can I introduce Robert Scoble?
Hey, how are you doing?
This is Richard Harper.
Yeah.
Yeah.
How are you doing?
Abigail Sellon.
Hey, how are you doing? It's for Channel 9, so we're not filming quite live, but hey, how are you doing? Great.
Doesn't a tripod need to have more than one leg?
So we're live, actually.
No, it's a monopod.
As it turns out.
No. It could only list. Yeah, like the sinking Belgrano.
This is good.
It doesn't mean anything, I reckon.
It adds some mass to it so that it doesn't shake so much. So.
I've given Robert just a very cursory overview of some of what's going on in this group, but maybe I can leave him with you for a few minutes to chat. Yeah. You can do it in here if you want.
Sure. Yeah.
Unless if you guys are in the middle of
Well,
something.
I've got to whiz off. But
Okay.
Just stay here for 2 minutes.
I was going to talk to you, but we can give you an overview. This is where thinking's done.
This is nice. Get a real working feel for what goes on in this group.
Yeah.
I don't know what your patch is, but in our patch, kind of human-computer interaction, it's a really big thing about how the head isn't in there, it's out there, which someone's been arguing for 50 years. This is where the head's work is.
I see a bunch of cool things on the table here.
Well, this is unrelated to this particular discussion.
Okay.
This is, other stuff.
Information in the world.
I think there's some objet true there I can get.
So just tell me shortly what you do.
Well, at the moment, what we're doing is we're going through the data for this thing called Home Note. I don't have a picture of Home Note.
Oh, I did mention HomeNote to you. This is
But it's basically it's a display board. It's a message board for the home.
Okay.
Which we're just mocking up on a tablet for now. And we've put it in 5 households. And
Yep.
so we're looking at how the people in different houses have been using it, which is pretty interesting.
And this is the board that people can text messages to?
Yeah, or scribble on top of.
Okay.
I didn't mention that.
Okay.
So it turns out that different households view it in different ways. And one has hated it and said, take it away. We got a couple who love it and don't want to give it up. And then a couple who are kind of So we're sort of going through why.
Who are the heirs then?
Pippa. She's being good-natured about it, but it's really
So I happened to hit the one who wasn't so
Well, she's kind of
enthusiastic, because I was in on this interview.
Yeah, she's kind of neutral. But your two quite like it, and yours sounds like they like it.
I think they like it.
Both of mine. So it's better. It's like sliced bread. You know the phrase?
Yeah.
Thinner than sliced bread.
Oh, okay. Yeah. So what's your preliminary research showing why they hate it or why they like it?
It depends on the nature of the household, I think. So in the household that didn't like it, it's a single mum in charge of a bunch of teens, and basically everything goes through her, and she wants everything to go through her, and she wants her kids to acknowledge what that she's asked for something to be done, right? And this is a one-way message board, so you can't respond back through it. So she prefers her mobile phone, so that everything sort of comes through her, and so that's.
The bigger argument is that you take the Redmond folks have this idea that the problem with email is triage. Right? Well, actually, all that means is you have urgent or non-urgent. Well, that's only one of the pairs of possible dimensions. You also have things which are one-to-many, need to know now, need to know tomorrow, need to know in this place, and bound up with that is the patterns of communication of different sorts of people. So this mother wants to be the centre of the communicative pattern.
Yeah.
Other households, it's much more democratic, where the broadcasting, the person to person, person to many, person to place, person to the kitchen, person to dad, all have different patterns. So that's what we're exploring.
Ah.
So we're just going through the data for the first time, actually.
Really interesting stuff. Well, we get to see it live, right? Right before, even before Bill gets to see it.
You also get a lot of play, though, right, with new technology, especially with tablets, because a lot of kids have never used tablets.
Yeah.
So they basically play, and we're not learning anything about the fact except that kids play, and there's no surprise in that.
No, I see my son who's 11, and he picks up text so fast compared to even me, who is a pretty advanced user, you know, compared to some people who just are very adverse to technology and can't pick it up, you know. So. Anything else you guys want to tell me about what you guys do?
So my name's Sharanzadi. I've just recently joined the group. This is my second month now. And I'm going to be doing some various stuff. So as part of the Home Note project, we're looking at redesigning it based on these sort of set of user trials.
Yeah.
And there's a whole bunch of stuff, so features for MMS, multimedia messaging, replying to text messages that you get on the Home Note. And then as part of some other projects, I'm looking at interaction with large displays, and in particular how these displays you can just walk up with any device and sort of share information with other people, take information.
You know, thinking back, I was just in Times Square 2 weeks ago, and there was a Nike ad there on one of the big, huge displays, you know, 50-foot display, and you could text the billboard with your mobile phone and control the design of the shoe up on the billboard. And they said, call this number and you can change the design, the logo, the color of the shoe. And it was running on 8 Windows. I met the guy who programmed it, and it's running on 8 Windows boxes, that, you know, all through the phone. But you know, that's.
Yeah, these
you never know where this stuff will show up.
I mean, public displays are showing up everywhere. I mean, And a lot of the time they're not non-interactive, right? So that's certainly another sort of aspect.
Wasn't it the movie Minority Report where the guy walks through stores and the displays are changing?
Yeah, it's context sensitive.
That future's got to come. So.
Absolutely.
Well, it's cool to meet you guys.
You know, Ken's involved in this classic story like that because Ken was very keen on what was called active badges, which became active bats. And actually, the genesis of those was because some of the geezers at AT&T or was then at Olivetti Labs liked Star Trek. And they had this idea of being able to press the button so people would know who you are. So you get beamed up, Scotty, this vision of being beamed up to the CEO's office at Olivetti in Milan, I think. And they built them. And thus, the future is created by Hollywood.
Yep.
You don't need Redmond, you don't need us, you just need Hollywood.
Well, the guy who runs Microsoft Research is a Star Trek freak,
Yeah,
right? He has a shrine of Star Trek. What's his name? I'm sorry.
That's Rick Ratched.
Yeah, Rick Ratched. Yeah,
Some of us don't necessarily approve, and we somewhat frown on this approach to scientific endeavour.
And so, certainly you can see it in some of the research, like, the guys who do the play table, right? But they did another one which looked like the Minority Report screen, which was a clear screen, and you could manipulate images with your hands.
Yeah.
You know, so you can certainly see where
That's right,
is Hollywood leading or is technology leading? It's a very interesting question.
That's right.
So, well, thank you very much. It's great meeting you guys and seeing a little bit of your early research. So.
Yeah.
Somebody just took off down the corridor I was going to grab, but I feel kind of bad just landing you in on her with no notice. But one of the things I wanted to point out is that most of what you've heard about so far is what falls into what I would call the socio-digital systems group here,
Right.
which is part of the computer-mediated living. Now, Natasa Milic-Frayling, who just took off, this is her office here.
Okay.
She runs another group in another sort of subgroup of my group called Integrated Systems.
Right.
And it has a sort of here she comes down. I'm very sorry to do this to you. But, this is Robert Scoble from Channel 9, and
Hey, how
he's
you
just doing a
doing?
little walk around MSRC.
Hi there.
And I was telling him about the socio-digital systems side of the computer-mediated living group. And I was wondering whether you might give him a little quick overview of the integrated systems.
Yes.
Yeah.
Would you be able to do that?
Yes.
So, first of all, what's your name again?
Natasha,
Natasha. And, yeah, come on in.
you want to say some of the stuff?
Sure, come on.
You mind if I hang around too?
Yeah, no problem.
So,
Have you seen the Channel 9 before?
Yes, I mean,
yeah, the research here has been on Channel 9 a few times, so.
I mean, actually,
Oh, here we go. Yeah. You're probably doing this for me. Okay.
yes, I was just doing some slides for, I was just doing some slides for Ken, but it is about integrated systems group.
Okay.
This group has been around for about 6-7 years.
Let me turn around here so the lighting. Can you
Yeah,
turn on
can
the
you-
lights?
Yeah.
That's great. Lights help. That's why Channel 9 doesn't have the lighting crew or the microphone crew, so we have to sort of think about these things. So, what's integrated living? You said.
So actually, it's called integrated systems,
Integrated systems,
and it's
okay.
really about trying to solve problems. And in order to solve problems, we need to think about technologies that we need to pull together.
What kind of problems?
So, for example, people who are accessing information online nowadays,
Okay.
because there's such a variety of resources out there, and it's an environment that is not really familiar to many people.
Yes.
They have to navigate through hyperlinked environment. People get lost. So we look at the problem, find out where the problems are, think about what we can do to improve it. Sometimes we need to apply machine learning algorithms to model users' behavior. Other times we need to do natural language processing to understand the content and represent the content. Then we have to think about the user interface design and evaluation of it. Often we need to think about architectures. We have to have a good backend to provide information that we expose in the interface. So that's what integration means, really pulling pieces together.
Now, do you study the like you said, accessing the internet? Do you study normal people and how
yes,
they're?
we go for normal people.
Yeah, well, I know, because I'm way off. My friends all call me the end liar, the outlier. Because I read 1,300 RSS feeds a night, and that's way off the scale of what's mainstream behavior.
Yes, it actually it starts in different ways. I mean, we have a number of spectrum of projects. Some of them really start with the pains that we experience as naive users, getting lost because we forgot the URL, it can't find it. And it's not in favorites, and it's not in history, where is it? So sometimes it comes from us. Other times it goes from observation studies that we may conduct, mostly to identify opportunities rather than identify problems.
Right.
And often also comes from our imagination. We say, okay, look, there are this number of technologies available now. What if we put them together? Or what might be interesting in the future? So it goes from different approaches. It's not always one single. And it's about inspiration, really, where you want to go next and what seems exciting.
Right. So when you find a problem area, what's the approach? Let's say you find a problem like people can't navigate from here to there. What's your process? How do you?
That's a very good question, because navigation is something you've looked at.
Yes. So the typical approach is think about what are the basic concepts that people can understand. So really going through some kind of design process, although it is about trying to find concepts that people generally deal with in normal life and bring them to them in this digital world. So we go through the design process and then we start prototyping. And typically we have good developers on the team who just do rapid prototyping. Then we first test it on ourselves just to see whether we are comfortable with it, and goes to a number of iterations. If that goes well, then we will be more brave and say, okay, now I think we are ready to release it to a wide audience and get the criticism. We have formalized studies, and this is normally done by HCI experts who would investigate what the issues might be. Then we start conversation with our product teams, see whether they observe similar problems, whether they are prepared to look at this problem, and what would be the best way to collaborate. So it grows gradually from different methodologies.
And where can we see the results of your research? Are you working toward improving product, or are you going to release a paper at a university?
I think both is the answer.
Yes.
Actually, I mean, you might want to mention about the MSN toolbar stuff that your stuff had up in.
I love
yes,
that toolbar.
yes. So. And our general strategy really is to think ahead, so not necessarily very tightly align ourselves with the product groups nor with the immediate customer, because they may have a perception that this is exactly what they need at this moment. So lots of our stuff has been done looking ahead, and a number of these things now are being considered by product groups about 2 or 3 years later, and because it becomes more apparent, after a while, after more people are using things, that there is an issue. So about 4 years ago, we designed an enhancement of the browser which captures a query, and then could do highlighting or summarization of a document or analysis of a document. And some parts of that went into a toolbar when it was released last year in March.
Yeah.
I'm not sure if you want the screen dump. I can show.
We've seen it. So.
Yeah. So other things are coming. Basically, we just continue working. We publish, we patent, if there's anything that's innovative, it's being patented, and then it's published, and then we start a dialogue with products.
Very cool.
Yeah.
Anything else we should know about?
I was just thinking about, I don't know what stage the smart navigation stuff is in terms of public
Yes,
public
it is
dissemination.
available,
Is it
yeah.
because that's something which was interesting based on Natasha's group did some quite detailed analysis of how people currently use the web, to look at how they use the back and forward buttons, and came up with a very much improved navigation mechanism, which perhaps you can explain.
Yeah.
Natasha.
Yeah, that's different. Wow.
Yeah. So for example, what been
Is this publicly available?
Yes, yes.
It
So
is. Okay.
let me just check this other thing so I don't have distraction of these. Give a clean screen here.
All right.
So what we observed is that people often get lost because the back button works on a specific model, which is called the stack model.
Yeah.
For computer scientists, that means a lot. For normal people, that means nothing. Basically, it means when you get to a page, you navigate away from page and return and go somewhere else. Whatever you've seen before is gone.
Yeah.
So you basically can't revisit things in the branches or a navigation tree from before. So we provide a very simple overview for people that can access everything that they've seen in the past.
Okay, let me just...
So, and with every of these, we can access associated a thumbnail image. So in this case, I'm just using very large thumbnails. I can actually get the whole page stretched. So these are the thumbnail images of things that I've seen
That's
a minute
cool.
ago. Okay. Furthermore, we have this similar
Now, how do we
feature.
get this?
Is
Is this IE7? I'm going to have to talk to Dean and say...
Exactly. Possibly, but let's not jump the gun.
Yeah, so this is almost like a short-term history.
Yeah.
And if you turn off the IE and you return to it, it will be there. So it's not lost as it was before.
Wow.
Because before we had a history associated with the window. Now it's across the applications.
Okay.
Furthermore, we also have these links here, which are actually prediction of things that I've done. You see, I was checking the Microsoft stocks.
Yeah.
And I was thinking,
How are we doing, by the way?
And then I was doing my web authoring last night and a couple of other things. So these are the things that are predicting what I have done in the past, recently or repeatedly. This particular prototype I have now is geared more towards the recent history. We have another prototype which will look at my repetitive tasks. So it will show me here MSN search, Google search, Yahoo, finance page, whatever I do frequently. So basically mines my history and exposes it in the toolbar. There is intelligence in understanding what I've done routinely, understands my navigation pattern, and also can adjust based on what I'm currently doing.
Wow, this is really neat stuff. So this came out of your research of studying how humans use the browser.
Yes, we've done two studies. First, an observation study, logging what people do, and then asking them what their intentions were. We understood the patterns, and then based on patterns, decided to create a model of navigation. Then we did the design, and some preliminary studies to the design. Finally, we deployed this with two sets of users in the business environment and at home. And then we monitored how they use it, just to understand whether this was useful to them and get feedback. Now, based on that feedback, we are redoing some aspects of the prototypes. But again, this is just research still. This is not product development.
Okay.
Yeah.
Wow, this is cool stuff. So we can certainly see how research could be used in a you can see an end goal to this.
Indeed, and I think you'll see like a range of things, from things where you can see, a relatively short-term possible application in a product, to things that maybe have a much longer-term future, but nonetheless, are looking towards, are just looking further into the future. Yeah.
Well, this is really cool stuff. Thank you very much.
Yeah,
You're welcome.
Great stuff. I can't wait to use it.
Thank you.
Thanks. Cool.
Right.
So any more?
No,
I think we're ready to go punching on the cam, unless you have something really. That was killer. I mean,
I suppose we could peek and say hi to Steve, since you see Liz. Just because there's lots of hardware around here. This is just to show you that we actually do build stuff.
I'm Robert
This is
Scoble.
Robert Scoble.
Hey,
Hi, Robert.
And who are you?
Steve Hodges.
Steve Hodges. And
Steve is one of our hardware researchers, and as you can tell, and he's really one of the ones who actually builds the stuff. You met Lindsay Williams last year, I think, on one of your
Mike Hall
did,
did,
on one of your channel things, and Steve is part of that same sensors and.
So are you guys building a sense cam here? Is that?
Yeah, that's one of the projects we're doing here. Yeah, and I'm involved in that as well. And yeah,
Because Lindsay showed us the sense cam.
Yeah, Lindsay's the main hardware person on that, and Steve has got a bunch of other things on the go as well. But,
Can you talk about any of them?
Sure. We've got what are we doing here? We're doing a couple of things. So I'm prototyping here a device, and the idea is so this is the microcontroller we're using, and this is the little display that we're using. And the idea is we're going to build a device that you might carry around with you, which you can use to try and express your emotional state. So you can interact with it, and then it can give you feedback with a.
So I could wear a badge that says I'm happy or I'm sad or I'm really,
and then
I'm
use
really
that.
mean today. Stay away from me.
So I think if this is what I think it is. This is I mentioned the Touch Talk project earlier. This is the hardware for that.
Okay.
Yeah. So and the idea is you might have a couple of these devices that were in some sense paired, so that you can interact with one and it will cause the other one to change the way that it appears or the way that it interacts with you. So it might vibrate or it might light up a different way or it might show some graphics.
Very cool.
So that's something we're.
Now up on your screen, I see what kind of software is that? I've never seen this before.
This is PCB CAD software, so it's for designing circuit boards. So if I want to make something like this circuit board here, which is a board I designed, then I draw out a schematic in one tool, and then I actually lay out the shape of the PCB, so where the tracks go and where the pads go actually get created in this program here.
That's cool.
I always like to come in here. There's some real work going on here. Right? Stuff you can see and real. Yeah, exactly.
Well, starting today, we have a tour of the hardware team and showing how a keyboard and a mouse is designed. But this is completely different kind of hardware than what they showed me.
More sort of research oriented, a little more speculative, I suppose.
Yeah. Anything else that you can talk about what you're doing?
I'm wondering what else. So one.
Put you on the spot.
Yeah, sure. This circuit board here, which I showed you, is actually what we do with this is we have a GSM modem.
Yeah.
So this is the guts of a mobile phone, essentially. So the idea is with this device mounts onto this circuit board, like so. And then we can also put a little GPS unit on here as well.
Wow.
So the idea with this is when it's battery powered, we've got this portable device that knows exactly where it is, and it can report that in, because essentially it can make a phone call and report back to a server. And so we're using this platform to prototype different applications and different ideas we've got about mobile computing and location aware systems.
That's really cool. You've got a cool office. There aren't very many offices like this in Microsoft. Most people are very software oriented, and you get all the cool toys.
Yeah.
And this reminds me a lot when my dad was a hardware guy in Silicon Valley, and he would have a layout like this working on various projects. So it brings me back to my high school and other times. So thank you very much. This is cool stuff, and I can't wait to see what you guys do.
Cool.